All right, so let's talk about aromatic compounds. And the first thing I want to do is cover some nomenclature so that we know what we are talking about. So the first thing I want to mention is that there are so many aromatic compounds, but the main one that we will cover is benzene. So which means that the nomenclature that I want to cover is also benzene. Okay, and so just a little bit about benzene itself. This is the structure of benzene, and benzene can be drawn with a circle inside as a hexagon or with the alternate double bond single bonds. Remember, the alternate double bond single bonds is supposed to be a conjugated system. All right, and so we will talk about the structure of benzene later on a little bit. Right now we're just doing nomenclature, but anyhow, so you can draw it with the circle or with the double bonds. It depends, you know, the circle is a lot easier and faster sometimes, but anyhow, okay, so first of all, that's about the benzene. Now regarding nomenclature, so here is benzene. This is also called an arene ring. And this is like if you really want to be an organic chemist kind of thing, this is the symbol phi, and you use phi H for benzene. Okay, if you wanted to, you don't have to. But anyhow, so that's benzene. Benzene is C6H6. Now, phenyl ring, which is if you take away one of the hydrogens, C6H5, that's going to be connected right here to something, and then it's going to end in YL, so that's a phenyl. Okay, so as soon as you know that anything ending in YL means it's connected to something, and generally it means that it's also minus one hydrogen. Okay, and so that's phenyl. And the phenyl has the phi but no H, right? Because there is no hydrogen in there. Okay, so the phi assumes that you already have the 5 hydrogens. Now there's another group called benzyl. In the benzyl, you have the benzene ring, but you have a CH2 attached to it. Okay, so C6H5, CH2. This is possibly the most confusing nomenclature because generally we want to call this one benzyl because coming from benzene, but this is benzyl. Okay, this is phenyl. So this is just something you have to keep in your mind as you go on. And yeah, we will talk about benzyl also, okay, for nomenclature for reactions. So you kind of need to know that. So first I want to tackle the mono-substitution. So with the mono-substitution, when we do the nomenclature, you're going to encounter two different kinds of nomenclature as usual, which is the IUPAC and then of course the general nomenclature. Benzene has been around for a long time. So benzene compounds also have, you know, a lot of general names for that reason. So now, which one should you follow? You can follow either one. I give you both depending on how I'm feeling that day. But you need to know both, and both are pretty simple. Some of them we'll see, okay, how it goes. But anyhow, okay, let's talk about halogenated benzene first. Okay, so remember benzene by itself is just benzene, C6H6. But now as soon as you have C6H5, it means something else is connected to it. And so here is chlorine connected to it. So it's chlorobenzene. The first names here are going to be the IUPAC names. And the second names are the general names. Okay, so you can call it phenyl chloride also with the phenyl as your substituent, right, on the chlorine. So, but not on the chlorine, I don't know. Anyway, so phenyl chloride, that's the substituent. And chlorobenzene. So bromobenzene, phenyl bromide, you get the idea. Okay. If you have an alkyl group like methyl group on it, you can call it methylbenzene. But toluene is really the most common name for it. And even in labs, you will find that people label their bottles with toluene and not methylbenzene. But methylbenzene is the IUPAC name, okay? But toluene is the most common name for this. And so, oh my God, I don't know why I have toluene over here. So that's definitely not toluene. Butylbenzene, T-butylbenzene. So you just go ahead and name the substituent over here. So that's the T-butylbenzene. This is not toluene. And then the last one that I have is with an alkene attached to the benzene ring, so that's called vinyl benzene. So vinyl is this group, okay, right here with this 2 carbons. So if you have a 2 carbon double bond attached to something, that's called a vinyl group, and so that's vinyl benzene, and this is also called styrene as the common name, okay, for it. you can also call it like phenylethene, but I wouldn't do that. Okay, that's like completely if your brain is shut down and you're like, I can't think right now of styrene or vinyl group or anything. If you say, phenylethene, you are still getting the right structure. Okay, it's just not the correct name. All right. Okay, let's look at the next one, and that's going to be now with the alcohol group on it. So when you have an alcohol group on it, that's called phenol, and phenol is also IUPAC name. Okay, so you can always hydroxybenzene, also phenyl alcohol, whatever you want to, but generally phenol is the accepted name. Hydroxy is generally used when there's other substituents on there, so then you call the OH group the hydroxy group. Okay, so we still need to know the hydroxy group as such. We didn't use hydroxy groups before, so this is the first time. Okay, you're encountering this. Okay, and then here this is going to be methoxybenzene. So here is the methoxy group, and then this is benzene. So anisole is going to be the general name for this. Now anisole is a very hard one to remember as methoxybenzene, because like anisole doesn't tell you even that it has a benzene ring in it, right? So it's nothing to do with benzene at all. The other name, the third name for this is methylphenyl ether. So methyl, phenyl, and then ether. Okay, so you can use methoxybenzene or methylphenyl ether. Anisole, if you don't remember, it's okay. I understand. Okay, all right. And then here, next one with the nitrogen group on it, NH2 group on it. This is called aniline. The NH2 group is amino group. Okay, so and then benzene. So amino, benzene. Now, aniline also we will encounter a lot. Until now, we have not dealt with nitrogen groups that much. We've done some substitutions and some things, but not a whole lot yet, okay? But now we're going to get into it. And then here is nitrobenzene, okay? And the nitrobenzene has a nitro group. Again, we have not encountered the nitro group yet in our study of organic chemistry, so now we are going to, okay? So nitrobenzene, and there is no other name for nitrobenzene, and you're probably thinking, thank God. All right, more now. So here, what I did, I put all the, carbonyls on one side. So these are all the carbonyls. So carbonyl with a ketone, this is called acetophenone. We're going to do nomenclature of aldehydes and ketones a little bit later also. So you can look into that, but there is another name for this. Okay, and I can tell you that I didn't write it. But the other name for this one would be the methylphenyl ketone. Okay, just like you do for ethers. So methylphenyl ketone, that's the other name for this. But acetophenone is what I'm going to give you for most part right now. Then with the aldehyde group, it's benzaldehyde. Now this one seems a little bit reasonable, right? At least you know there's an aldehyde group there. And then the last one here with the carbonyl is the carboxylic acid, and that's benzoic acid. Okay, so all of these names that you're learning right now, like aniline and acetophenone, these are very different kind of names, very unusual, and also very specific structural names. You have to remember these. Okay, so the best thing to do is to just not bother too much, but just go ahead and memorize it. Okay, don't think about that, oh my God, I will figure it out. You can't. Okay, so just memorize them. Okay, and then here are some of the benzyl nomenclature. Okay, so benzyl bromide would mean that you have a CH2 attached to the benzene ring. Okay, a phenyl bromide is without the CH2, benzyl is with the CH2. And then here is benzyl alcohol. I just wrote them differently so you can see what they might look like, but really a CH2, this is also a CH2. Okay, so it's not really structurally any different, it's just visually it looks different, and I want you to be able to look at all these structures and not be confused as to saying that, oh, this is written differently. Okay, by now you should be comfortable with the line structure as well as formulas. Okay, so that's the benzyl group in there. Okay, and I don't think I have anything more in here for mono substitution. So now for the dye substitution. So when you have dye substitution in benzene rings, just like any other cyclo compound, you can have a 1,2 substitution or a 1,3 substitution or a 1,4 substitution. You move one more and then you're back to the 1,3 because then you're counting from the left side. Okay. In benzenes, we have very specific names for the 1,2, 1,3, and the 1,4 substitutions. And so for the 1,2, it's ortho. For 1,3, it's going to be meta. And for 1,4, it's para. Okay, so ortho is right next to each other. Meta, if you want to think, it's in the middle. And then para is parallel, okay, to that, if you want to think like that. Okay, so those are the other names for it. Now you can use whatever you want. You can use 1, 2 or ortho, meta, para. Okay, so I've given you examples over here for both, and both are valid, and I can also give you both. Okay, either of these names I can give you. So the first one here, let's just take 2 chlorines on there. So 1, 2 dichlorobenzene, ortho dichlorobenzene. So ortho tells you the location of the dichloro in there. Okay, so the 1,3 dichloro and then meta dichloro 1,4 would be then the para dichlorobenzene. Okay, so that's how you would name these. Now some of the other substituents you can have on there. So for example, you have a CH3 and an OH. When you have something like this, now you have to decide, what do I do with this? Okay, what base name do I give this? Do I give this the base name of toluene, or do I give this the base name of phenol? Okay, and either case it's fine. I would say take the easy way. Okay, why not? All right, so take the easy way, whatever is easier for you. And actually in this one, the first one, everything is easy. Okay, because both of these groups are pretty straightforward. You have the methyl group and you have the hydroxy group, okay, over here. So meta-hydroxytoluene or meta-methyl phenol, both of them are okay. And then 3-methyl-hydroxybenzene. So 3-methyl. So hydroxy means that you're giving the hydroxy number 1, 2, and then 3-methyl-hydroxybenzene. Okay, so anything is fine. Any of these names is okay. So just remember that when you have 2 substituents, the main thing is, what do I want to give my base name to? Okay, so here when you have NH2 and Cl, choose aniline. Okay, although you can choose amino group also. So here I've done that with aminobenzene. So 4-chloroaminobenzene or para-chloroaniline. Okay, in some cases you don't really have much choice because I haven't taught you yet how to name CHO by itself. Okay, I have shown you how you can name OH as in hydroxy, but I haven't showed you how to do for CHO, which means that you have to name this compound as benzaldehyde, which means orthohydroxy benzaldehyde. That's how you would name this one. Okay, so that's kind of the pattern. Okay, so you kind of know what the basics are now, so just follow that through. Okay, so let's look at the tri-substituted benzene derivatives now. And in this case, you cannot use ortho, meta, para because you have 3 substituents. So once you have 3, you have to give numbers. Okay, so for example, it's a simple one like this. You have 3 of the same groups here. So 1, 2, 3, 4, 5. And so this is 1,3,5 trinitrobenzene. Very simple, straightforward. Now, if you have something like this where you have a CHO group, Cl, NH2, so now you know that the CHO group, you don't know what it's called. So better to give that the base name, which is then the benzaldehyde. And then how do you start numbering? Do you go left or do you go right? Okay, and so in this case, we go right so that we can follow the alphabetical formula also. Okay, so here the 2 is then amino group and then 6 is chloro. Okay, so try to give lower numbers and then also follow the alphabetical nomenclature, that rule that we have. So that's 2 amino, 6 chloro benzaldehyde. So now when we're looking at something like this here, we can give this one the name of toluene and deal with the 2 OH groups separately. So toluene means your numbering starts from this carbon with the methyl group on it. So 1, 2, 3, so then 3, 4, 5, so 3,5 dihydroxy toluene. That's how this one goes. And so you get the idea. Okay, so here is another toluene, and now then you have the 2,4,6 trinitrotoluene, which coincidentally is also TNT. Okay, that really is TNT. Okay, anyhow, so that's the tri and more substitutions, right? This one is 4 substitutions on there. So some of the diols and some of the benzenes that we have, they actually have general names, which I'm not covering as much because it's hard for you to remember, I know. So for example, if you have two methyl groups on a benzene, this is called orthoxylene. So the two groups here, that's the ortho. Xylene is when you have two methyl groups. So if it was, over here, the methyl group was on the meta position, it would be metaxylene and so on. Okay, and so that's xylene. And then chrysols. Chrysols are where you have a CH3 group and an OH group. Okay, so again, you can have ortho, meta, para, chrysol. And then when you have the two OH on there, with the two alcohol groups, okay, so one alcohol is phenol, but when you have two, then your names are actually quite different. I haven't given all of the names here for you, but depending on what the relationship is, ortho, meta, or para, their names can change. So this one I've given you for hydroquinone, there is one resorcinol, and so on. So I don't expect you to remember all of these names. I need you to remember the basic names that I gave to you in the first two slides. Okay, those are the important ones, because that's the fundamentals. Okay, when you start getting into more than one substituent, then things start getting more, I wouldn't say complicated, it's just too much to remember. We don't need to do that. Okay, at this point you can always look in the book for that. Then there are also some heterocyclic aromatics. Now, we haven't done aromatics yet. Okay, we are going to, but these are kind of compounds that you encounter, in your lab life, in your chemistry life. So, here are some names. And the ones that I would say you will need to remember a lot are the first three over here. Okay, on the left side. So pyrrole, furan, and pyridine. Those ones you encounter a lot more in the lab. The other ones depends on what you're working on. Okay, so thiophene. Thio stands for sulfur groups. Okay, in organic chemistry. And nitrogen is actually aza, but it depends on how how we're doing the nomenclature. All the names given to you here, these are all general names. None of them is the IUPAC nomenclature. Okay, although some of them are acceptable as IUPAC, but I haven't given you those. Then we have polynuclear aromatics, in which the benzene rings are kind of fused together. Do I need you to remember all of this? Not for me, okay, but I'm just telling you this is possible. Okay, so if you have two benzene rings fused together, that's called naphthalene. If there are three, it's called anthracene. Once you have three, then you can have constitutional isomers, because those three rings, how are they connected? So depending on that, the name can change. Okay, because now the connection is in a different point. So things change. Then you have four rings, five rings, it can go on and on. Okay, so these are polynuclear aromatics, and they all have very specific names. I want you to understand the difference between a fused ring and a connected ring. Okay, so when they're connected together with a bond, when the benzene rings are connected with a bond, this would be biphenyl. Okay, because there are two benzene rings. When they're fused together like that, what does it mean by fuse? Okay, fuse means that when you have these two carbons, you have two joints. Okay, over here. Here you only have one bond. Okay, that's connected to another benzene ring. But when you have two rings joined together by two bonds, not a double bond, okay, but like in two bonds like this is called fused. Okay, rings together. So this is also fused, right? Even though they have more than two things, two bonds, okay, fused together. So that's kind of what fusion means, okay, for aromatic compounds. Some of the physical properties that we kind of need to go over for benzene compounds is boiling points are a little bit higher than alkanes. Um, it's not super high, but by the time you get to 6 carbons, right, the smallest aromatic that we are dealing with is benzene, which is C6. So the corresponding alkane would be hexane, okay, for that. So they're kind of corresponding. They're not that much higher. But the thing is, when you deal with benzene, okay, you're not just dealing with benzene itself, because if you were just comparing benzene with alkane, then it's just a hexane and benzene thing. You're also comparing a lot of the other substituents that we have on the benzene ring, so phenol, acetophenone. So a lot of the boiling points will depend on what is on the benzene ring itself, okay. And so usually what will end up happening then is that you will have higher boiling points, okay. So just to kind of note, like if you have an OH, then of course phenol will have hydrogen bonding much higher than what you might have for something like acetophenone, for example. Okay. Solubility in water. Generally, benzene derivatives are not soluble in water because as you have C6H5 or C6H6, which is highly nonpolar, right? You have so many carbons in there, so definitely not going to be soluble. Even if you have OH groups on there, now unless you have like 5 or 6, that's a different thing. But even otherwise, phenol is also not that soluble in water. So generally, no. So density then depends on what kind of substituent you have on the benzene ring. Again, we're not just talking about benzene here, we're talking about the substituents also, okay. So this is a problem. I mean, I put this slide in here just to kind of talk to you a little bit about the physical properties, but otherwise there is no real trend that you can follow, okay. So density can be greater or lower depending on what the substituent is, okay. So generally, like in labs, you work with benzene and toluene. Those are generally going to be lighter than water, okay, and so or less dense than water. So it depends, what you're working with. So don't take anything for granted for density and boiling points and all of that kind of thing. Odor is definitely distinct because aromatic compounds, the name actually comes from aroma, and so therefore they do have smell, and usually the smell is quite pleasant for a lot of the aromatic compounds. Applications of aromatic compounds is unbelievable. I mean, it's just hard to put down in one slide as to what the applications are for aromatics because they're found everywhere. So solvents, definitely. So in the lab, you can find benzene and xylenes and toluene for your reactions because they're not very reactive, because that's how you want your solvent to be. So they're not very reactive, and so they're very good solvents. You just have to kind of look at the boiling points and see if that suits your temperature or not, but otherwise they make for excellent solvents. They're non-polar, so they can dissolve all sorts of organic substances. Pharmaceuticals, meaning that, a lot of medications that we take, they actually have a benzene ring. I will encourage you that if you have even the simplest of the medication at home, like Tylenol or aspirin or anything, just look at the structure that's given to you in that little sheet of paper inside it, and you will see that a lot of the medicines that we take actually have benzene ring inside it, so in the structure. Different substituents all around it, that's a different thing, but otherwise they have benzene in them. So a lot of drugs are designed with pharmaceuticals. The main thing about the pharmaceutical and or the medication is about how the medicine is working inside the body, right? So when you have a benzene ring in there, it creates a non-polar group, okay, for attachment, for bonding, for transportation, all of those things that people consider when designing a drug. Naphthalene, very specifically, is known as the mothballs, okay, which we all know. We all use at home also as a disinfectant, sort of pesticide, so it kills bugs. And so remember, anything that can kill bugs can also kill you. So be careful when you're, working with any kind of mothballs, or if you're, opening up your warm clothes that you kind of kept away for the winter time or for summertime, I should say, sorry. Then, when you open it up, kind of air it out. Okay, don't open things at home and leave it in the closed room. Okay, just air it out for a bit and then bring it in because naphthalene can be toxic. Styrene, which we saw vinyl benzene, okay, that's very common monomer for making polystyrene, which we know, we eat in polystyrene all the time. All the takeout food, that's all polystyrene. Polystyrene is, it's extremely common. The problem is, of course, you can't recycle it, right? That's a huge, huge issue. So, but polystyrene is a very, very common polymer, all right? So that has a benzene ring in it. Benzoic acid is used as a preservative, so which means you actually consume benzoic acid. You don't want to consume any of the other things. Pharmaceuticals, yeah, my goodness, we eat so much aspirin and Tylenol. But anyhow, so benzoic acid is a preservative. And then the last thing I just want to mention to you a little bit about benzopyrenes. And benzopyrenes are very potent carcinogens, okay? And benzopyrenes are actually about uh, 5 rings fused together. Because I showed you the fused rings, in one of the previous slides. And the fused rings, actually, the more you fuse them, the more dangerous they become. Okay, so 1-benzene also is actually quite bad for you. It's carcinogenic. When we work in the lab, we are very careful. Okay, when we use these compounds or these compounds as solvents, we're very careful. The naphthalene is getting bad, right? Naphthalene is 2 benzene rings fused together. By the time you get to benzopyrenes, which are like 5 rings fused together, I mean, we're talking about serious carcinogens over here, okay? And so where do you find these carcinogens? You find them as a byproduct of tobacco. So it's not just nicotine, okay? Nicotine is a whole different thing. But the way cigarettes are made is that they are rolled up in cellulose and whatnot, right? So there's the whole thing about making a cigarette, okay, that's actually what causes the formation of benzopyrenes, because cigarette by itself is nothing. You have to light it up, so which means you're lighting it up, not you per se, but again, when someone lights it up, you're giving heat to that substance, and then reactions are going on. Those reactions then will produce benzopyrenes, and benzopyrenes, even in like micrograms, even smaller quantities than micrograms, can be extremely toxic. Okay, and it depends, like sometimes people smoke, they're chronic smokers, and that's what leads to cancer then. Okay, so one has to be careful, and this also goes in the secondhand smoke. So one has to be really careful working with aromatics, as beneficial as they may be in the formation of drugs. A lot of the other things are actually not very good about benzene, but we can't live without benzene either, okay, and their derivatives. It's really one of the most useful um, base, that we end up using for making other things. So that's it. Okay, make sure you learn all the nomenclature well. Regarding the physical properties, there's really not much to do there. So that's it.